2 of... All right, so first one we're going to look at, I'm going to solve for R, actually R2. All right, so we're going to be rewriting equations so that instead of saying that R equals, we want it to say R2 equals. And some of these I'm going to know what they are, and some of them I don't know what they are. Some of them are just random formulas. All right, so we want to get R2 by itself. So I'm going to pretend like this is a regular equation, and if I want this by itself, I need to get rid of R1. How would I get rid of R1? I would subtract R1 from both sides. Just like if it was a regular number, that's what I would do. So this becomes R minus R1 equals R2. And so I just got R2 by itself.
What is the reasoning? Why would you want R2 by itself?
Why would I want R2 by itself? Let me give you the next one because I think that one will make more sense. This one, it's more of an abstract one. So let me do this next one, and then maybe I can answer that better. Okay, so let me give you a real life example because I know what this one is. All right, we're going to solve for R, and this is I equals PRT. Okay, this formula is your interest formula, and it stands for the principal, your rate, and your time. Okay, and if you take your principal, your rate, and your time, you're going to get your interest over here. Now, this is wanting us to get the rate by itself. They want you to solve for R. So let's say that you work for a bank and you deal with this all day long. You want to write basically like a little mini program so that you can punch it all into your calculator and not have to solve an equation. So you manipulate equations to make your life easier. Because if let's say I don't know how long something is, then I would want to get T by itself. Or if I want to know the principal, then I would want to get P by itself. And then that way you can use it over and over and over again on your calculator and not have to solve an equation each time. Does that kind of make sense? A little bit? All right. So we want to get R by itself. Okay? So I need to get rid of the P and the T. Well, what operation is going on right here? Multiplication. So the opposite is division. So I'm going to divide this side by a P and a T because that will allow the P's and the T's to cancel out. I'm going to divide this side by P over T, and then I'm going to have R equals I over PT. So I have R equals I over PT. All right, let's look at this one because this one I talked about yesterday. All right, we're going to solve for M. All right, this was the formula I showed you yesterday. This is that slope-intercept form, which we're going to do a lot with here pretty soon. Okay, right now I have y by itself. It's very helpful to have y by itself because later on you're going to learn that that's your slope and that's your y-intercept. Okay, but let's say that I don't want y by itself. I want m by itself. What do I need to get rid of? Okay, and which one do I have to start with? The b. So instead of adding b, I need to subtract b. So now I have y minus b equals mx. And then what do I have to do? Divide by an x. Now, you're going to see this written two ways. Here's why earlier I was saying you're going to have to know all the ways it can be written. Okay? Sometimes they're going to leave it like this, right? Because I've taught you that. How else did I teach you how to simplify things that looked like this?
Oh, you can split it.
You can split it. So sometimes answer keys will start here, okay? Or some answer keys are going to go a step further and do this. And you're going to have to know when you check it that those two are the same thing. And it really just depends. Sometimes they're going to put another variable here, and so if they put another variable here and it cancels out with the x, then you're going to have to do this step. Okay, but here this would be optional. Either one of these would be correct on this one. They would both be right. Carter.
Isn't it M and not X?
Oh, did I just put the wrong thing? Thank you. Sorry. I put the X's on the bottom. I just wrote the wrong thing there. All right, let's look at one last example one. And this is why I'm going to give you guys some time in class today to work with a partner. And then I'll have an answer key back here that you can check to make sure you're getting it. All right, so we're going to solve for V. And I get C equals Q over V. Okay, now this one gets a little trickier because you have to think outside the box here. Joanne? Okay, now here's the thing. Let's say I multiply by Q. If I do that, Q times Q is Q squared, and I didn't get rid of anything. Well, what's dividing by Q going to do? That's what I would do. I would multiply by the V. And I would do that because if I multiply this by V, these V's are going to cancel out, right? And I multiply this side by V, and now I have CV or VC, doesn't matter, equals Q. And then what would I do? Divide by C. So it's kind of like I had to do this kind of reverse thing. Do you guys see why earlier when we were in the beginning of chapter 3, I said it's not good enough to be able to solve these in your head? Yeah. Do you see this is why the process was so important to me, that you understood the process and not just the right answer? Because otherwise you have no clue of how to do this. Okay? All right. Yeah, that is how you'd have to leave that one. Because there's no other part to break it down or do anything else with.